we're going to show you how to use the Calibrator app to help get the most out of your structure sensor. What can I use the Calibrator app for? Well, with the Calibrator app, you can fix the depth coverage so the sensor can detect objects via a process called stereo image refinement. If your sensor isn't seeing objects properly, or if you're losing tracking, the stereo image refinement may be able to alleviate those problems. And you can also calibrate the sensor if the objects in the color are misaligned through the standard calibration. Our sensors leave our manufacturing facility well calibrated, but still sometimes physical impacts can create a discrepancy between the sensor's twin infrared cameras. The result is similar to if you were to cross your eyes. The sensor won't be able to converge the two IR feeds to generate full depth coverage. This is called an IR offset. Unfortunately, it's not a physical defect of the sensor, and in most cases this can be easily fixed with the stereo image refinement. Symptoms of an IR offset include no depth coverage, bouncing bounding box, instant tracking loss, or the inability to capture a scan. Here's an example of a sensor with an IR offset on the left versus a scanner with proper depth coverage shown on the right. Now you can tell the sensor on the left has poor depth coverage because the color overlay is incomplete, the bounding box is bouncing, and it's just losing tracking, whereas the sensor on the right has a full color overlay and it's consistently reading the object. First, make sure your sensor's glass plate is clean. If you haven't already, remove the plastic film from the sensor, and if there are any smudges or fingerprints, clean them with rubbing alcohol and a microfiber cloth, wiping in small circles until clean. Next, you want to be in the right environment. The SIR can only be performed indoors as the infrared rays from the sunlight will flood the sensor with IR light. You'll also want to find a blank, featureless wall that's neither black or reflective, and you'll need to stand at least 3 to 5 feet away from the wall. So now we're going to open up our Calibrator app and make sure you have the most up-to-date version of the Calibrator app through the App Store. When it opens up, it's going to look for the wide vision lens. Just slowly pan the camera left or right. If you don't have a wide vision lens camera, don't worry, just move past those steps. Now you're going to click the question mark icon in the upper left-hand corner. Now click Perform Refinement. A tutorial will pop up where you'll just swipe left to read through the tutorial. It will then show you an example of a misaligned sensor on the left versus an aligned sensor on the right. Continue to swipe through the tutorial and it will show you an example of how to face the wall. And when you're ready, you're going to click Start Refinement. Just stay still as the refinement will finish automatically. And if you're happy with the refinement, you can click Save Refinement. If you're not, you can always restart it. The correct alignment should cover about 90% of coverage within the inner 70% of the map. Great, and now you can see the stereo image refinement is complete. The next thing you can do with the Calibrator app is to run the standard calibration. Now, why is the standard calibration important? The structure sensor works in tandem with your iPad's color camera. The iPad's camera applies the high definition color and texture of the objects being scanned, while the structure sensor captures the depth. The problem is, the two cameras exist in two different places, and if run without calibration, this would produce effects where the color from one object may shift over into the color of another. And you can see that this sensor in the example is poorly calibrated because the scan overlay is not aligned with the object, and when we look at the color of the scan, the color is inaccurate and misaligned. The sensor stores its calibration values locally, and it associates them with the iPad that was used to calibrate. Once your sensor is calibrated properly, you won't need to do it again for a while, if ever. Now open the Calibrator app to follow the prompts, and click Start Standard Calibration. If you're using a structure bracket, you'll press Begin Calibration. But if you have a custom bracket, swipe right and enter the XYZ values for your bracket, and then press Begin Calibration. Now when you do start it, a split screen will appear with the color image feed on the left and the IR camera feed on the right. Now a pop-up may appear that says insufficient sunlight, but please don't run the standard calibration outside, as too much infrared from the sunlight will oversaturate the sensor with IR. The sensor is very sensitive, and oftentimes, standing still for a few moments allows the sensor to pick up the light required for the calibration, or you can move closer to a window. Alternatively, if this message doesn't go away or if you don't have enough sunlight, you can toggle the Enable Indoor Mode button on, which will adjust the exposure and gain to allow more light in. The next stage calibrates the color and infrared of the sensor, or what we refer to as the Pollock calibration. Now the goal here is to find a complex scene that's high enough in contrast that it appears well in both screens. And we found that the Jackson Pollock painting 1 number 31 is actually the perfect scene to pick up on these complexities, so we've assigned it as our indoor calibration target. You can download and print the indoor calibration target with a link in the video description. So during the stage, you're going to point the cameras at the target and stay still until it moves on to the next stage. Next, we have the final stage, which is the refinement. This is where you manually drag the depth's color feed overlay to match the physical scene. So you're going to start with a tutorial to practice on a simulated scene of the table and chairs. You're just going to drag the feed left and right until the color matches the physical edges of the chairs and table. Now it's time to do it yourself. So face something like a solid edge, like a desk or a door frame, something that has a solid distinction between two distances, like this open door. Now I'm going to match the color along with the edges of that door and the door frame. And when it's lined up, you can click Save Calibration. The calibration state will save to the sensor and you'll be ready to scan. So just to test the new calibration, you can open up your scanner app. And I'll point this at the desk lamp here. And as you can see, the overlay matches exactly with the physical object. And the scan is matching perfectly. Thank you for watching. Be sure to follow us on social media for news and updates, and watch the rest of our videos to learn more about the structure sensors. You can download the Calibrator app from the App Store, and visit structure.io to learn more.